So, we have deduced Lorentz transformations between two inertial frames, which is consistent with the two postulates of special theory of relativity. And the transformation equations that we got are x prime is equal to x minus v t over square root 1 minus v square by c square, y prime is equal to y, z prime is equal to z, and t prime is equal to t minus x v by c square, and then square root 1 minus v square by c square. Primed coordinates are coordinates of an event in S prime frame, and unprimed quantities here x, y, z, they are coordinates of that same event as seen from S frame. Similarly, t prime is the time of that event as seen from the clocks of frame S prime, and t is the time of that same event as seen from S. And S and S prime, they have a very definite relationship, because under that only we derived all these things. S prime is going in positive x direction with velocity v, that v is here and in x direction, positive x direction, and x prime axis are coincident, y and y prime are parallel. So, all those things are there under which this is deduced. Now, if this is the transformation equation, then we have several beautiful results that can be derived from here. The first one is length contraction. So, what we call length contraction. So, if I have to measure the length of a rod or a table or any material object, or the distance between two points. So, that is also a length. So, if I have to measure a length of a material object or just in space itself, how do I do that? So, if that length is at rest with respect to me, for example, table. So, I have this table and I need length of the table. So, what do? I can put a meter scale or a tape, measuring tape, and then I can go to the left end of that length and measure what is there on that measuring tape. Then I can come to the right end and measure the value on the measuring tape, and then I can subtract x2 minus x1 and I can get the length of this table. But what if the table is moving with respect to me with some velocity? So, if the table is moving with respect to me with some velocity, I can put the tape there and I can still note the reading on the tape, which is just in front of the left edge, and then the reading on the tape of the edge which is just opposite that, and subtract. But we have to be very careful that the two readings must be noted at the same instant. If the table is at rest with respect to me, there is no restriction. I can measure the left end and then leisurely I can come to the right end and measure. But if the table is also moving, then I do not have this liberty. The moment I have measured the left end, at the same moment I have to measure the right end, and then only I can subtract. So, that is to be kept in mind when we are calculating length of a moving length. So, let us say we have a frame S prime, and in that S prime frame there is a length from here to here this point is, let us call it A, let us call it B. You can take it like a rod AB, and this is the left end of the rod, this is the right end of the rod, and I need the length of this, and this length is parallel to the x axis, let us say x prime axis. So, what is the length? What is the x coordinate of this A? That is x A prime. What is the x coordinate of this B? That is x B prime. So, I have two events, in fact, measuring the end A and measuring the end B, and then the difference between these two will be the length. So, let me call it L naught. Let me call it L naught. L naught is equal to x B prime and minus x A prime. And there is no restriction. You can measure this end at any time, and you can measure this end at any other time or same time. There is no restriction on that. This will be the length of this rod. Now, this is called rest length. This is called rest length. Why? Because it is measured from a frame in which this length does not move. This A remains at the same position, B remains at the same position, same coordinates. When I say same position, means same coordinates, x A prime and some y prime, z prime 0 you can take. So, same position. So, since this length is not moving within this frame, and the measurements are being done from this frame only in which it is at rest, and therefore, it is called rest length. What if we have to measure length of this rod from S frame? So, if I have S frame, and in that S frame I have my observers, my measuring tape and everything, and from this frame I want to measure the length of this AB, then what I have to do? I have to measure the two positions, the x coordinates of the two ends A and B at the same instant, and then subtract. So, first event will be your first event is E1, measure the left end. So, suppose I get a value x A, the coordinate there is x A, and when? At time t. So, x A and some y A and z A, and the time is, let us say, t. And then I have second event E2, and the second event is I have measured the right end. So, measured the right end at the same instant. Remember, now I have to measure the two ends at the same instant, because the whole thing is moving. So, I cannot afford to do one measurement and then relax and then go to the other end. So, at the same time, and the coordinates will be, let us say, x B, and time is t. So, these are the measurements, and therefore, the length of AB will be x B minus x A. This is the length of AB as seen from the frame S. Now, these two events E1 and E2 we will transform to S prime using Lorentz transformation. So, these two events E1 and E2, I know the position, I know the time, I know the position, I know the time. So, this event, if I take the S prime frame, what is the corresponding coordinate, what is the corresponding time? So, for that we will be using Lorentz transformation. So, from S prime, event E1, what is the coordinate? This will be, let us say, x a prime, which will be x a and then minus v into t divided by square root 1 minus v square by c square. That is the Lorentz transformation. X prime is x minus vt divided by this factor. So, x a prime will be given by x a here and then minus v into t. So, this is E1, x a here and t here. Now, come to E2, event E2. The x coordinate is xb and the time of this event is this t and this t have to be same. So, xb and t, from there you can write for E2 xb prime is equal to xb minus vt divided by square root 1 minus v square by c square, and therefore length of AB in frame S prime is xb prime minus xa prime equal to xb prime minus xa prime. So, when you subtract this Vt is same here, Vt is same here, and therefore, when you subtract this will cancel out and you will get xb minus xa and then divided by this. So, this is equal to xb minus xa and then divided by square root of 1 minus v square by c square. Why this is a length? Let us look at the time also. Let us do the transformation equation for time also. So, if I do the transformation equation for time, the first event, the left end was measured. When did it happen? So, you can write Ta prime. So, Lorentz transformation, this will be Ta minus xa v by c square divided by square root 1 minus v square by c square. And similarly, you can write for Tb prime. Tb prime will be Tb minus v xb by c square and then divided by square root 1 minus v square by c square. So, you can see that Tb prime and Ta prime are not same, but does not matter. Does not matter. If the coordinate of left end A is this much at some time Ta prime, it will always remain that, because in S prime this AB is not moving. In S prime AB is not moving. So, whatever is the coordinate of left end A at one instant, that will remain there all the time, and therefore, this is the coordinate of left end A. And similarly, whatever is the coordinate of right end B at some time Tb prime, this will remain this much for all time, and therefore, even if these two measurements are done at different times, Ta prime is not equal to Tb prime, even then it remains the left end coordinate and this remains the right end coordinate, and therefore, xb prime minus xa prime is the length of AB in frame S prime, and that is the rest length L naught. And what is xb minus xa? Xb minus xa is the length of this AB in S frame, which is the moving length. This is the moving length. I am measuring the length of AB and AB is moving with respect to me. So, now let us write this in words. This is rest length. This is rest length. So, rest length is equal to, and this is moving length. xb minus xa, this is moving length. xb minus xa is the length measured from a frame in which this length was moving. So, this is moving length, this is moving length. So, rest length is equal to moving length divided by square root of 1 minus v square by c square. Look at this properly, we will be using this again and again. Rest length, that means length measured from a frame in which that length is not moving, that is rest length, and that is equal to moving length. So, now I am using a frame in which this length is moving with a velocity v, and that will be moving length. So, rest length is equal to moving length divided by this, and remember this square root of 1 minus v square by c square, this is a number less than 1, and if you are dividing by a number less than 1, you are increasing the magnitude. So, rest length is greater and moving length is smaller. So, moving length is smaller than the rest length, and this phenomena is known as length contraction. And as I said, it is not a material property, because in this whole derivation I have not used that there is a material between A and B. Even if you have two pillars at A and B, and I ask what is the distance between these two pillars, it is only space, there is no material there apart from air, etc. That length also will be changed by the same equation. The separation between two poles from a frame in which these two poles are stationary, and the separation between the poles from a frame in which these two poles are moving will be different, and the rest separation will be more than the moving separation. So, this phenomena is known as length contraction. So, this is known as length contraction, and this is one consequence of Lorentz transformation, and it happens to be true. It is not that from Lorentz transformation we have gotten this. Yes, we have gotten this, but it does happen in real life also, although in our general life, daily life, this V is always very small as compared to C, so we do not notice it. But that contraction of the lengths do happen if you move that particular length. So, this is length contraction. Now, the next topic is called time dilation. Time dilation. So, we are considering now time interval between two events from one frame and from other frame. So, there are two events E1 and E2. How much is the time interval using the clocks of one frame and using the clocks of the other frame? So, we will start with a frame in which the two events are taking place at the same position. So, we have two events E1, let us talk from any frame, S prime frame. So, let us talk from S prime frame. So, in S prime frame, the first event has occurred at some position, say x1 prime, and where, or say x prime, and when at time t1 prime. So, some event has taken, some event, some chalk has been broken here, this is an event, some event, or some particle has reached at this position, this is an event, or something has been measured at this particular time at this particular position, so that is an event. So, some event has taken place and as measured from S prime frame, its position was x prime and its time was t1 prime, first event. So, t1 prime. I am not writing y and z. So, you can assume that all these things are happening on x axis, or if y z are there, let it be there, y prime will be equal to y, z prime will be equal to z, and this will have no effect on the equation that we will be deriving. So, I am only writing x and t. Now, there is another event E2, and let us suppose that it happens at the same position. So, this x prime and this x prime, they are same, but at different time, say some later time. So, I have a bulb, suppose I have a bulb here, and then I put on the bulb, and after some time I put off the bulb. So, the two events have taken place at the same position in my frame, in this room frame for example, let us say. So, in this room frame I am standing here, and then at this place itself, after some time I said okay, done. So, these are two events. My lecture starts, when I am here my lecture starts, one event, and then my lecture is over, that is another event, if I am not moving here and there, and my final, I can move here and there, but finally the second event is again at the same place. So, in a particular frame, if the two events are taking place at the same position, so that is the kind of event E1 and E2 we are considering. So, the time interval between these two events E1 and E2 is T2 prime and minus T1 prime, and this is called proper time interval. This is called proper time interval between the events. So, if you have a frame in which two events are taking place at the same position, then the time interval between those two events is called proper time interval. So, here we are taking these two events of that kind where they are occurring at the same position, and therefore, this time interval which is measured in this frame is called proper time interval. Now, let us calculate the time interval between the same two events as seen from the frame S. Okay. So, now we are writing from S frame, and in S frame we are writing the time of this E1, time of this E2, and look at the interval. Same story, S prime is moving with respect to S. In S prime you have at the same position two events, and in S frame first event has taken place, frame is moving. So, second event has taken place somewhere else, right. So, if in S prime frame these two events have taken place at the same position, same x prime, but at different times. So, when this first event E1 has taken place, that time suppose bulb is put on, bulb is put off. So, bulb is put on at this position, but then after some time the bulb is put off, but in this time the bulb has already moved, and therefore, the second event is at some other position. Now, I am not interested in position, I am interested in time. So, what is T1 prime for E1, for this event E1? What is T1 prime? It is here. What is T1? From S frame, what is the time of this event? That T1 will be given by the Lorentz transformation, reverse transformation. So, reverse transformation will be x is equal to x prime plus Vt divided by square root 1 minus V square by C square, and y is equal to y prime, z is equal to z prime, and t is equal to t prime and plus and x prime V by C square divided by square root 1 minus V square by C square. So, I will be using this. I will be using this. So, T1 is equal to T1 prime. So, T1 prime plus x prime into V. So, x prime for E1, x prime into V by C square divided by square root 1 minus V square by C square. And then second event. For the second event, what is the time? When did it occur? As seen from S frame. So, here it is T2 prime, and in S frame that time will be T2. So, T2, and T2 will be similarly T2 prime plus x prime. So, the position of this E2, that is again x prime, this x prime and this x prime are same, and so it is x prime times V divided by C square and then divided by 1 minus V square by C square. So, this is the time of event E2 as measured in S frame. So, what is the time interval between two events, these two events E1 and E2? So, that time interval will be T2 minus T1, and that T2 minus T1, this minus this will be T2 prime minus T1 prime, and this part will cancel out. This part will cancel out, x prime here, it's same, V by C square here, V by C square is same, and this factor is always there. So, this will cancel out and it will become T2 prime minus T1 prime divided by square root of 1 minus V square by C square. So, the time intervals between two events, this is also relative. If I have put on the bulb and after some time I have put that bulb off, how much time the bulb was on, that time interval is also relative. If I am measuring from one frame, it is something else. If I am measuring it from some other frame, it is something else. So, this is the kind of relation T2 minus T1 is equal to T2 prime minus T1 prime divided by this. And what is T2 prime minus T1 prime? This is very special. This is measured from a particular frame, a very special frame in which the two events have taken place at the same position. In all other frames which are moving with respect to this property will not be there, and hence this is called proper time interval. So, this is proper time interval and this is improper time interval. So, improper time interval is equal to proper time interval divided by square root of 1 minus V square by C square. So, improper time interval is greater than proper time interval. You are dividing by a number which is less than 1. So, proper time interval is smallest of all time intervals that you can measure from different frames. The smallest is here proper time interval, and it is the time interval from a frame, I repeat, in which the two events have taken place at the same position, that is proper time interval. So, we have derived two equations, one is on time interval and other is on length, moving length. Moving length is equal to rest length and multiplied by square root 1 minus v square by c square. This we had derived, this is called length contraction. The rest length is the largest length, and if you measure from some other frame in which this is moving, that will be reduced. So, that is known as length contraction. The rest length is also sometimes known as proper length. So, this is also called proper length and this is improper length. So, improper length is smaller than the proper length, and then here improper time interval is proper time interval divided by this. So, proper time interval is the smallest time interval and the rest length is the largest length, and always collect your formula in these forms, not in these type of forms, because S and S prime is our choice. So, do not try to remember that T2 minus T1 is equal to T2 prime minus T1 prime divided by this and so on. If you do that, then you also have to remember that the two frames, the two events took place at one position in S prime, then only this is valid. I can also start with two events taking place at the same position in S frame and then measure that time interval between the two events from S prime. Then this will be inverted, it will be T2 prime minus T1 prime equal to T2 minus T1 divided by square root 1 minus v square by c square. So, it is better to remember this kind of interpretation, that your proper time interval is the smallest one, and from any other frame if you measure it will be increased. So, that is known as time dilation. So, we will stop here, and there are more interesting results from Lorentz transformation next class.